Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Mo's Algebra 2 class. Today, guys, we're going to continue with logs, and we're talking about logarithmic functions now. Exponentials and logarithmic functions literally are inverses, okay? They're inverses. Let me explain how this works. A logarithmic function, guys, is defined by y equals log of base b of x, okay? Let's examine this for a second. It looks like this is my answer, right? Right? This is my base, right? And actually, this is wrong. This is my exponent. And this here, x is my answer. Now, this is an inversion of exponentials. Why? Well, b to the y power equals x. On this case now, let's think about this. My x is what it equals. Well, my y is what it used to equal, correct? And I have x inside here. Now I have y here. So what happens is logarithms and exponentials are literally inverses of each other. When we truly analyze log base b of x equals y, we got to remember a few different things, okay? This b right here, guys, that b is called the base. That is the base. What's the base, Moto? Well, if I have 5 to the third power, my base is 5, my exponent is 3. So when I'm reading log base b, that's my base. X is the actual answer. That is what the answer is. Okay? And y is my exponent. Okay, y is my exponent. Okay, does that make sense? So log base b of x equals y can be turned into b, the base, to the y power equals my answer x. These guys, okay, that's how I can convert from one to the other. And convert from one to the other. Now, log base b of x equals y. It's literally read as log base b of x, but I like to read it as log base b to the y power equals x. Because if you can really understand that this b is being raised to the y power, I'm telling you, you're going to have magic happen. You got to know how to go from that log format to that exponential. So log base b to the y power equals x. Make sure you really understand that. And if you don't, I will do my best to re-explain it any way I can. There are two main types of logarithms, y'all. You have the common log, which has a base of 10. And it can be written as either log base 10 of x or just simply log of x. If you do not see a base, if there's no base, that means the base is 10. That's why in your calculators, you will have a log button. If you notice, it's not log, and then it leaves a blank for the base. It's just plain log. And log means that it has a base of 10. That's common log. Natural log, guys, natural log, okay, has a base of e. Remember, e is Euler's number. Remember that e to the first power is roughly 2.71. And also, for those of you who are having troubles with their calculator work, if you ever want to test it, just put e to the first power. If you did it correctly, it's going to be 2.71, and it keeps going on, but we can round it to 2.71. Okay, so ln is another button on your calculator, and ln is simply a log of a base e. Now, we mentioned this before. Exponential function and logarithmic functions are inverses. Y equals b to the x power, and log base b of x equals y are inverse functions. Okay, we talked about this already. Now, let me talk about a very powerful situation here. When I have a base b raised to the log of that same base, guys, they cancel, and I'm left with just my answer. What is this man talking about? If I give you, for example, 8 to the log base 8 of 6, this 8 and that log base 8 cancel, and I'm left with 6 right off the bat. Done. Okay? It has to be greater than 0, though. If you ever have a log of a negative number, it's wrong, it's not defined, you cannot have it. It's impossible. Okay? And then if I have log base b of b, again, these guys cancel, and I'm left with a. So if I have a base raised to the log of that same base, they cancel. If I have a log of a certain base times the same base, they cancel. Okay? And again, please note the log key on your calculator is only for common logs, base 10, and the ln key is only for natural logs, base e. A lot of times people will see log base 2 of 12, and they'll go, oh, log of 12. You're going to get it wrong. Because log base 2 of 12 is way different than just the log of 12. Okay? So now, let's practice. Let's rewrite each exponential expression as an equivalent expression involving a logarithm. So, okay, remember, guys, just so you can understand where my brain is going. Equals. When something equals something, that's an answer. Right? This is my base. And this right here is my exponent. Well, let's just think about this. Log base b, so base of 5, of the answer, in this case it's b, equals my exponent of 4. Does everyone see that? Okay. How would this next one be? 1.9 to the c power equals 12. Yes, sir, my brother. Log. Excellent. Log base 1.9. No. Of the answer times 12 equals c. No, but remember, this c is the exponent. But when we're putting it into log form, the exponent becomes my answer. Okay? So, what about w to the 1.2 equals 7? What would that be? Yes, sir, my brother. Talk to me. Yeah? Log base w, good. Not to the 7th. Of the 7th of 7 equals 1.2. Guys, remember, log base b of x equals y. Guys, I'm not trying to be rude. What does of mean? Multiply. The log base b is being multiplied to the x, and it equals y, the exponent. You feel me? All right. Now let's go log to exponential. What's the base here? Yeah. So 3 to the y power equals 81. How about here? What's my base? Okay. So a to the negative 3 power equals 1 over 27. Excellent. How about here? What's my base? So 4 raised to the second power equals x. Now we're going to learn how to solve these very soon, but it's very simple, okay? For example, let's just get a little ahead. This is 3 to the y power. 81 can be turned into 3 to the 4th power. Whenever you have an exponential equation and both bases are equal, they cancel and y would equal 4. Ding dong, the witch is gone. Now, a to the negative 3rd. Okay, I know that if I have a to the negative 3rd, it brings it down. So let's see this. I have a to the negative 3rd equals. What number to the negative 3rd power will give you 1/27? Yeah, 3, right? Right? Right, guys? So because this is a, well, rather, a will equal 3. Because 3 to the negative 3rd power equals 1 over 3 cubed, which equals 1 over 27. So my a is 3. Does that make sense? And of course, last but not least, x equals 16. So as much as this looks crazy, It's amazing. It's really simple, very easy, and I think it's kind of fun. All right, find the exact value of each. Okay, now we're not just converting, now we're finding the exact value, guys, okay? We need to find the exact value. So basically, we're trying to find, I love it when it does that. So basically, we're trying to find what that equals. This should be the y, right? The exponent, right? Well, that's what I'm looking for. When they tell you to evaluate it, they want what the exponent is. What is that value? What is that answer? So 2 to the y power equals 32. How on earth can I turn 32 into a base of 2? Talk to me. Y will equal 5, but let's not confuse everyone. But I'm so proud of you. Thank you, my man. This is 2 to the y power equals 2 to the 5th power, guys. 2, 4, 8, 16, 32. When the bases are the same, y equals 5. That's my answer. 5 is the answer. Now, some people don't put the y there. Some people put just random variables. Me, I like to stay consistent, okay? Here, log base 5 of 25. Well, 5 to the blank power, to the y power, equals 25. Well, that one's going to be easy. Y equals 2, right? Because 5 squared is 25. The 5's cancel. Y equals 2. Log base 4 of 1/16 equals y. Well, 4 to the y power equals 1 over 16. Guys, what did I do to make that 4 a 1 over 16? Yes, sir. Thank you, my brother. Fantastic. Y equals -2. Because 4 to the -2 power is 1 over 16. How about D? F of 2. If f of x equals log 2 of x. Well, f of 2 then will equal log base 2 of 2. Hey, wait a second. What happens when I have a log of the same base times the same base? They cancel. My answer is 1. I'm really proud of you guys. I see you writing a lot of stuff down, and I thank you for that. I don't want to jam you up or go too fast. Let me know when I can continue, guys. Please. I'm going to pause it for a second. I see a lot of people writing. All right. Thank you for that. Okay, now, graphing logarithmic functions. Okay, we're not going to go crazy with this, guys, just like exponentials, but I got to show you what logs look like, and I got to talk to you about a little bit of log stuff because you're going to see it, and it's not that difficult. I want you to stress out. Just like all functions, logarithmic functions can be reflected, stretched, compressed, shifted to the left or right, and shifted up or down. So let's see how that works, okay? My exponential parent function, why did I say exponential? Why did I say exponential? It's a logarithmic. That's my bad. The logarithm. My bad, guys. Please change that. Parent function is y equals log base b of x. Okay? Where b is greater than 0, of course, and b cannot equal 1. Now the complete logarithm, why did I do that? Function is y equals a log base b of x minus h plus k. Please don't stress about this, my brothers. Let's talk about this a, this h, and this k again, because we talked about it with absolute value. We talked about it with quadratics, and now we're talking about it with logs. Here's the thing. Any function you guys are going to see now or later in life, in math, this a, this h, and this k have the same exact properties. I promise you. So a stretches, compress. It's either stretches, compressions, and or reflections. A stretch occurs if the absolute value of a is greater than 1. Okay? That means it's going to stretch, so it's going to become thinner and thinner. It's going to become narrower and narrower. It's kind of like a rubber band. Okay, guys, you can't see it out there in the computer world, but my kids can see this. If I take this rubber band here, all right, just tie this here, and I want a vertical stretch, okay, a is greater than 1. Watch. What happens to the rubber band? I know it stretches vertically, but what happens to its width? It gets narrower and narrower and narrower. A compression is reversed. A compression is if the absolute value is between 0 and 1. So a compression is like squishing a car in a junk pile. It goes this way. Oh, so it becomes a lot wider, okay? And it gets compressed down. A reflection occurs if you have A is less than negative 0, and that's going to be a reflection in the x-axis. So what that means is, remember when we were doing what? Remember when we were doing sorry guys, remember when we were all right, yeah, sometimes it takes a few times. I apologize. So when we have y equals, let's say, 2x, it was going to look like that, right? But if I have y equals negative 2x, it's going to look like that, right? Well, isn't that a reflection over the x-axis? So whenever a is negative, you're reflecting over the x-axis. B is the base. We know the base. H is going to shift the graph to the left if you see a positive, and it's going to shift it to the right if you see a negative. And it determines the vertical asymptote and domain. The K shifts the graph up or down. Now, all of that is the same for any function you're going to use in life. Okay, domain. Domain of a logarithmic function, guys, is found by setting the x minus h to not equal 0. You can never, ever, 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 ever have a negative value for log as far as the x goes. Why? This is a logarithmic function, the most basic of all logarithmic functions. Okay? And the way this works is, as you can see, this guy right here, this is my asymptote. I'm going to get real close to that y-axis, but I'm never going to cross it. And the log function goes like that. Okay? If it was negative, then it would go like this. Okay, yes, sir. Here's the asymptote right here, my brother. And it's a y equals 0. Remember, the asymptotes and everything here is reversed from the exponentials. Remember that an exponential, I'll do it in green right quick. An exponential goes like this, right? Or like this, right? Well, let's think about it, my brother. Isn't the x-axis the asymptote? Right? Well, in this case, didn't we say that the logs and the exponentials are inverses? So if the x-axis was the asymptote for an exponential, then the y-axis has to be the asymptote for a log. You feel me? Okay. Now, let's graph. Okay. How do you graph this, Mr. Moro? How do you graph this? Well, guys, I'm not going to let you use a calculator on this, and on the SAT, they're not going to let you use a calculator either. All right? So what happens is you have to be a master of converting. What is g of x really? Another name for g of x? Okay, y. So this is y equals log base 2 of x, right? You ready to rock and roll? Can't I convert this into 2 to the y power equals x? Okay, now, who's the independent variable this time, guys? No. Who's the independent variable? The y. Remember, guys, exponentials and logarithms are inverses, okay? They're inverses. So I'm going to choose values of y. That's what I'm going to choose. And I'm going to choose negative 1, 0, and 1. 2 to the negative 1 is 1/2. 2 to the 0 is 1. And 2 to the 1 is 2. So now I have 1/2 negative 1. 1, 0. And 2, 1. So this guy here goes like that. And I can never cross my asymptote. Now, remember what we said. This comes from a log base b of x minus h plus k. Do I have an h here? No, when my h is 0, that's why my y-axis is the equation, because what's the equation of the y-axis? X equals 0. Okay? If I had the same exact thing, guys, but I had y equals log base 2 of, let's just say, x minus 3, okay? Let's say I had that. I could go ahead and graph my parent function, and then guess what, guys? I'm going to shift every point 3 places to the right because it's always opposite the sign. So this would have gone 1, 2, 3 to the right, 1, 2, 3 to the right, 1, 2, 3 to the right. And now this would be my graph. And guess what? X equals 2 would be my asymptote that I cannot cross. Please take a look at that, guys. I know that this is pretty heavy stuff, especially for the end of the year. I know we're kind of, tired, but I want to make sure I'm doing my job. Does that make sense? Yes, sir, my brother. Thank you. Correct, my brother. It's always reversed. What my boy asks is, Moro, you said x minus 3, you go to the right. Why are you flipping it? Because remember, it's x minus h. So if h equals 3, it's x minus 3. But the h is 3, so you go to the right. So when you see a negative here, you go to the right. When you have a positive, you go to the left. Because if h was negative 3, then it would read as x plus 3. Thank you and brilliant. Okay. Find the domain of each log. Don't stress, you don't have to graph. Just find the domain. It's all right here, baby. X plus 1 cannot equal 0. So x cannot equal negative 1. So my domain, let's picture this. This logarithm function here, there's an asymptote here at 1. Don't logs go like that? Isn't it going little by little to the right? So my domain here would be from negative 1 in a parentheses because it's not equal to positive infinity. Those are all the valid x values here. If you look at log base 6 of x minus 5, just take a little quick sketch of that. We got here at the 5, that's my asymptote. So that means my function will go from 5 to infinity also. So we've got my domain equals negative 5 to positive infinity. Some of you may be saying, Moro, why is it that you're using parentheses, not a bracket? Why am I using parentheses, not a bracket? Because it cannot equal negative 5. So it's not included with using a parentheses. So you'll never get a positive number. Come again, my brother? You'll never get a positive number on the y-axis. Correct, sir. And wait. Hold on. Wait, why did I do that? That's positive. Yeah. That was stupid of me. Oh, no. Yeah, that was stupid of me. Because x minus 5 equals 0. Yeah, so you're going to get a positive number, poster. X cannot equal 5. Not negative 5. I messed up. X minus 5 is 5. Not negative 5. Sorry, kid. Okay? And actually, here I misrepresented this as well. Moro. That's correct, but my drawing was horrible. It's negative 1. Ding dong. From there I go. So this would be, negative 1 to positive infinity. You feel me? So if you ever ask for a log, the domain of a log, look at that x and h, and set that x minus h not equal to 0. May I continue, boys? All right, now, evaluate each using a calculator. Yay! All right, this is the fun part. Guys, literally, if you have your calculators, go ahead and take them out. If not, pay attention and focus. I want to find the ln of 20, so literally hit the button ln, hit 20, literally, and that's it. Let's go ahead and go to the thousands place. Some of you guys don't know how to round to the thousands place, so we're going to go over it. So this is 2.9957. My brothers, no sarcasm. Tens, hundreds, thousands. But you got to round, guys. 2.996. I let some of you slide on the quiz. I will not let you slide on the test. If you don't know how to round, I am going to mark it completely wrong. Log of 30. Remember, that's not log base 30. That's a log. So that's log base 10. So I can hit my button log, then hit 30, and bada bing, bada boom, 1.4771. So round it to the nearest thousands, 1.477. ln of 0.5 or ln of a half. ln 0.5. And that's going to be negative 0.6931. Rounded to the nearest thousands equals negative 0.693. Okay. Now, how do we solve? You may be thinking to yourself, Moto, what is wrong with you today? You're killing us. No, actually not. Everything builds. Check it out. Don't be afraid of this. This log, guys, is going to be real hard for me to solve using log. But what can I turn a log into? An exponential. So isn't this 2 to the 4th power equals 3x plus 4? Be honest, is that hard? Don't stress this out, guys. You can do this. I know you can. So let's do it. 2 to the 4th power, 2, 4, 8, 16. So I got 16 minus 3x plus 4. I'm going to subtract 4 to both sides, brothers. I get 12 equals 3x. Yes, whoever said it, good job. You beat me. X equals 4. Fantastic. Thank you. Great job. Great job. Does everyone see that? Promise? How about for B, my brothers? We'll do it in blue. How would I set up B? Because we sure as heck cannot do it like that. What's up, my brother? X to the 2nd power equals 25. How do I get rid of a power of 2, my brother? You square root it. That's right. So then X is going to equal, thank you, plus or minus 5. However, no, yeah, plus or minus 5. However, let's think about something, guys. What did I tell you about B? Look at your notes. What did I tell you about B? Can never be negative. So my real answer is X equals 5. Yes, sir, my brother. Okay, the question was, how do I want it on the test? Do I want to see X equals plus or minus 5 and then the transition to 5? Or can I just put positive 5? I'm not going to stress that too much. Yeah, I need to see the work. But yeah, if you already know in your head, like for example, me, I'll never put plus or minus in these because I know they got to be positive. And then I have ln of x equals negative 2. What's the base of ln? What's the base of ln? E, guys, isn't ln the log base e? So this is e to the negative 2 equals x. So now, in your calculator, guys, there is a minus sign and there is a negative sign. The negative sign is encapsulated in a parentheses. The minus sign is next to the operation keys, plus, minus, multiply, and divide. But the negative symbol is a little minus sign. It's a lot smaller than the minus sign, and it's usually in parentheses on your calculator. So what you're going to do is, on my calculator, I'm going to read, I go second function. So I'll go second function, and I'm going to hit the ln. And when I hit the ln, I'm going to pop out a little e, and it's going to be raising to some power. And that's where I'm going to now activate my negative, and then I go 2, and my answer will be 0.13533, rounded to the nearest thousands, tens, hundreds, thousands. We got 0.135. Does that make sense? Questions, comments, concerns, problems, issues, dilemmas? Sir, my brother. Can we get with the calculator? Let me see. Okay, so you're going to go second function, e, and then negative 2. Thank you, my brother. Now, last but not least, I believe. Yeah, all right, cool, we're good. All right, the loudness L measured in decibels of a sound intensity X, measured in watts per second per square meter, is L of X equals 10 log of X divided by 10 to the negative 12. If normal conversation has an intensity level of 10 to the negative 6 watts per hour per square meter, how many decibels is a normal conversation? So loudness measured in decibels, so L is the decibels, and the sound intensity is X, right? So let's plug in, guys. I want to find L when X is 10 to the negative 6. So we learned this yesterday. Replace every x in this function with 10 to the negative 6. So I got 10 log of 10 to the negative 6 over 10 to the negative 12. Is everyone with me so far? This is going to give me 10 times log of 10 to the negative 6 divided by 10 to the negative 12 is 10 to the, no, to the positive 6. Okay, you with me here? Yes, sir, I brought it up, absolutely. Because when you subtract the same base, when you divide the same base, you subtract the exponents. Now, here's the kicker, guys. Focus. My brothers, what's the base of this log? What happens when you have the log of a base times the base? They cancel. Right? You guys with me here? So what's my answer going to be? 60, guys, because you have that 10 there, right? So my answer is going to be 60. Okay, I heard someone go, what? Okay, hold on. Let's not worry about it. What's log base 10 of 10? Guys, what's log of 10? What happens there? Cancels. Where does that 6 go? Just disappears? No. 6 times 10 is 60 decibels. dBs. Does that make sense? Do you promise? Yes, sir, my brother. Come again? Well, because I just followed the formula. Okay, thank you for your honesty. Okay, we've got here 10 log of x over 10 to the negative 12, correct? So I want to find L of 10 to the negative 6 because that's what I was asked to do. So this is going to equal 10, right? So y equals 10 times log of 10 to the negative 6 over 10 to the negative 12. This equals y equals 10 log of 10 to the 6th. But what do we say happens when you have a log of the same base times the base? They cancel and that will equal 6. What's 6 times 10? Perfect timing. Wow, I'm glad we reversed it today because it was a long lesson. Guys, tomorrow we will review 11.2 and 11.3. Thank you. Great class. Hope you learned a lot. May God bless you, and I'll see you on the flip side. Bye-bye.